Okay, so this is Amanda Martinez, and this is my reassessment on work energy and potential energy. So the first thing that the question asks you is that find the maximum distance the block travels up the frictionless incline if theta equals 30. So to find that, I know that the energy stored in the spring is converted to the work done on the block when it travels up the inclined plane. So I use my potential energy of a spring equation, 1/2 ks squared, and set that equal to force times distance because work done is force times distance. And I know that we're solving for distance, so I know I have to find the force. So I labeled all my forces acting on the block, and I had to resolve my x component of the incline to find the force acting in the x direction, which would be mg sine theta. So you get 1/2 ks squared equals mg sine theta times d, and then you just solve for d, and you get that the distance was 1.275 meters. And then part B, they ask you how far the block is going when it's halfway to its maximum height. So I drew another little diagram over here to make it easier for me to work this one out, because now I know that the distance is 1.275 meters, and when it hits that's the max height. So I want to find h over 2 and how fast it's going when it hits h over 2. So the first thing I know that what we have to do is we have to find the max height that the block travels. So in order to find that, I made this into a right triangle. Here's like my 90 degree right here, and I know that sine of theta is opposite over hypotenuse, so sine 30, because we know the theta is 30, so sine 30 equals h max over 1.275 meters, and then you solve for h max, and you get that the maximum height the maximum height that the block traveled to was 0.6375 meters. And to find h over 2, you just divide that by 2. So then you get h over 2 equals 0.31875 meters. And then to find the velocity of that, the energy in the spring, to find the velocity of the block when it hits h over 2, you have to know that the energy in spring equals the kinetic energy plus the potential energy of the block. And I use the energy conservation relation, which is energy in spring equals kinetic energy plus potential energy. And so I use the potential energy spring constant again and set that equal to 1/2 mv squared plus mg h over 2 because we're trying to find the velocity when it hits h over 2. So then I subtracted mg h over 2 to each side, and I solved for v, and I got the velocity when it goes to h over 2 is 2.5 meters per second.